All right, well, today is June 29th, 2018, and right now at 8:30 a.m. we have a temperature of 64 degrees here in the foothills of Los Angeles. The relative humidity is 70%, and the dew point is 54 degrees. We've got a barometric pressure of 29.95 inches, and today, for the first time in about 6, 7 days, we have overcast skies. The last several days have been clear. We haven't seen any clouds in the skies here in the Los Angeles area for many days. We've seen some uh, the day before yesterday, the previous 2 days before the day before yesterday, we saw some dissipating chemtrails on a couple of high flying jets, and the normal commercial flight traffic was not leaving any aerosol trails. So that's an important distinction when people look up in the skies and they see some jets flying and not leaving a trail, and then we see some other jets that are leaving trails. That's uh, needs to be looked at. We know why that's happening because some of these jets are specially equipped to spray the chemical aerosols into the skies. All right, so today we have a very heavy marine layer over uh, the Los Angeles area right now. Currently, we're looking at the East Pacific Rainbow Loop, the infrared map. And this is Emilia right here. This is a tropical storm. And this storm is developing 60-mile-per-hour winds. Let's take a look at the Hurricane Center map. Here's Amelia right here. Uh, 60-mile-per-hour winds. Central pressure of 997 millibar. And this is moving west-northwest at 12 miles per hour. Now, right behind Amelia, we have another disturbance with a 70% chance of hurricane formation in 2 days. So we're going to keep an eye on this as well. The track for this storm here is to move basically in a west-northwest track until Wednesday. So we'll keep an eye on this, and let's go ahead and look at that map again. We can see that Amelia is being targeted. We can see a blast pattern right here on the eastern side. That ring right there, moving out towards the east. Let's go ahead and look at the, we can see the icicle pattern there on the outside of that as well. So this storm is being targeted by a satellite transmitter that is superheating the interior, disrupting the convection, superheating that water vapor, and of course, superheated water vapor expands much like steam. If you have a pressure cooker on your stove, you turn the heat up, and you've got water in that cooker, the pressure is going to build, and it's going to want to escape. And so what happens when this storm is targeted, the water vapor is instantly superheated, and that causes this blast pattern. That's what we're seeing right here. Let's go ahead and look at the rainbow map once again, the infrared map. And we can see that pressure wave right there on the outside, at the very end of that loop. So this is being done uh, at different periods. In other words, this is being targeted at different periods. Every half hour, we can see that actually this entire map sequence is a 7.5 hour loop. And so it looks to me like they've hit this a couple of different times during this 7.5 hour loop sequence. Now, looking at the visible light map, we can see some pretty good detail. Let's go ahead and stop the map. We can see that we have the night to day transition coming up. And then right here, we see a dimple mark, that little right area right there, which looks like a hole right through the center. That's where the center, that's where this system was targeted. If you go back, we can see that one frame captured the event right there. And let's go ahead and scroll through, and we can see what happens. You see the pressure develop, and we have this area right here. And that causes the blast pattern right out here on this outer edge. Go ahead and run that. So the system is targeted, and then we can see the blast pattern develop, pressure wave right there moving out towards the northeast. This happens a couple of different times during this sequence, this loop sequence. This storm is developing very slowly compared to the earlier storms here the last 3 weeks, which spooled right up to Category 3 and 4 hurricanes, and then they were squashed. They were completely superheated and basically neutralized. These are taking, this one here and the one previous took a little bit of time to spool up. So that's because of the fact that these are being targeted. They're not being allowed to generate into a full-fledged hurricane. So here we see the bigger map, the Northeast Pacific water vapor loop. We can see Amelia right here. Also, we see an area right here, just in northern Mexico. This is a low pressure system that is being targeted. Let's go ahead and look at this on the next set of maps here. This is the southwest map. We can see that right here we have a low pressure system that's trying to develop, and this area is being targeted. Look at all the turbulent activity right here. And then we see a couple of straight edges. We have a straight edge here and one right along right there. So there's a low pressure system trying to develop right in this area near New Mexico and Arizona. That is being prevented. Looking here at the rainbow loop, we can see all that turbulent activity, and we can see the degradation of the moisture right here. Take a look at that. Look at all that turbulent activity right in here. That's a satellite transmitter breaking down this area. So we have a low pressure system in this area trying to spool up, and that is being prevented. Now looking here at this map, this is the Northeast Pacific. Once again, we can see that, watch what happens here. We have a hole that opens up right towards the end. Right down here. Let's go ahead and take another look here. See, right up here is where we're looking. And so we have this odd circular feature right here adjacent to this developing hurricane, and that is neutralizing this area of low pressure. And we haven't had any monsoonal moisture moving up. Take a look at the big map here. Once again, we can see that a lot of times during this time of the year, we see a lot of monsoonal moisture moving up towards the southwest. So that's been prevented pretty much. Right here we see what's happening. So there's no rain here anywhere in California today. Looks like I don't have the telecast map up. Looks like there's probably no rain in Arizona or New Mexico. This is being broken down, that weather system there. See a pressure wave right here moving out, right here. This area is being superheated. We see a couple of straight edges. And once again, we see some pretty good evidence of weather manipulation going on. Now, we'll come back to that map. This is the surface analysis map for the East Pacific. We can see that we've got low pressure indicated here, plus a trough. Right here on the west coast, we have a, pardon me, a developing gale right here indicated. We have Amelia indicated down here, 60 mile per hour winds. And let's move to the next map. We have the unified analysis. This is the west side of the country. We have a low pressure indicated here and a big trough running right down into Mexico. We have a low right here. This is the one that has the right angle on it. It is being superheated. We've got lows all over the place out here in the west. Yet there's no rain here in California. Cold front indicated here. Now, looking at the east coast, you can see a area of weather moving into Canada. This is a giant, looks like a supercell of developing thunderstorms right here, about the size of that hurricane or developing hurricane Emilia. This is a very large area. Looking at the rainbow map, this is all red, very deep red right here. These maps, the East Coast maps, use a different color template, so that's why we're seeing this green here. That's down over here on the scale. And we see some weather moving out through the off the East Coast. The people in New York and that area are going to start feeling a heat wave here pretty soon. And we've got some thunderstorms down here in the right here in the Gulf of Mexico. Looks like right down here. Okay, let's take a look next at the pressure maps for the West Coast. Sea level pressure, we see that we've got a closed low right here over eastern California and Arizona, right there. We've got high pressure right here indicated. And of course, we have this area of high pressure that's installed out here, middle of the East Pacific. And a low right behind it. At the 500 millibar level, we see this closed high right here installed in place. And we have a high down here. And look at this. Look at these squiggly lines indicating a manipulation by transmitters right here. This is the area where this developing low pressure is being superheated, and we see these squiggly lines. These isobars should be very smooth all the way through, all over the place. These should not have these squiggly curly cues like what we're seeing right here. So this is an indication of transmitter manipulation right where we're seeing that developing right angle where this weather system should be dumping some rain in New Mexico. Now, if you look at the 300 millibar map, we see more squiggly lines right here. So that's the evidence that we're looking at. And this coincides with what we're seeing on the map, the right angle, the pressure wave, and all that. Out here we have a closed low pressure at the 300 millibar level. We're seeing that here indicated on the 500 millibar map. This is just north of the Hawaiian Islands, by the way. Let's go back and look at the map, the large map. We can see that counterclockwise rotation right here, just north of the Hawaiian Islands, right here. And then we have another one in this area, just to the east. So we've got low here, one there, one over here. We've got thunderstorms right just west of the islands, probably about 1,000 miles right here. And then we have Amelia. Okay, so that's the situation. We're going to keep an eye on Amelia and also this system right here. All right, we'll just leave it right here. And quickly we'll take a look at the, this is the swell report for the West Coast. We have some high swells moving into Central California right here, 12 feet. And down in Southern California, we have 6 foot, 9 foot seas moving in. We've got 12 foot right here, just right off of, looks like basically the Monterey area, just south of San Francisco. Okay, that's it.